Today's goal is to find and verify inverses using graphs and tables. Inverses, keep in mind, are functions that undo each other, or equivalently, you can think of them as functions whose inputs and outputs have been switched. Sometimes you see this diagram, for example, with a trig function. You take an angle, for example, the sine of x takes an angle as its input and spits out a ratio of side lengths, or a y value, as its output. Whereas the inverse function takes as its input the ratio and its output is an angle. Okay, let's take a look at example 1. Fill out the tables of values below, then use the table of values to sketch a graph of inverse cosine of x. So let's take a look. We remember that cosine is all the x values, so the cosine of 0 would be 1, cosine of pi over 2 would be 0, cosine of pi, it's the x value of the coordinate pair, and back at 1. So for the inverse function, we're going to switch the inputs and outputs. This time 1, 0, negative 1, 0, and 1 become the inputs of the x values that correspond to the same y values. Okay, so we filled out the table of values below. Now use it to sketch. So for the x value 1, this time we'll have the y value 0. The x value 0 will have the y value pi over 2. Oh, excuse me. We have the point 1, 0. Sorry about that. We have the point 0 pi over 2. We have the point negative 1 up pi. Now we have the point 0, 3 pi over 2. And the point 1, 2 pi. We remember that the cosine function, the regular cosine function, looks like this, right? It looks sort of like you're connecting curves or unwinding a circle. And so if we don't want to fill in more points, we have to sort of keep in mind that shape. This will look like you are unwinding parts of a circle or tracing pieces of a parabola, right? There's in between those 2 points. Okay, so we have a nice sketch. Does your graph produce a function, y or y not? Some people think of a function as a sketch that passes the vertical line test. That is, for one x value, you're only allowed to produce one y value. But we see, for example, the x value 1 produces 2 different y values, 0 and 2 pi. And the x value 0 produces the 2 y values, pi over 2 and 3 pi over 2. So as we've drawn it, this is not a function, inverse cosine of x. It would only be a function if we cut part of it off. Let's say, for example, we want to keep this part of the function. Well, now the x value 0 only produces the y value pi over 2, and the x value 1 only produces the y value 0. And in fact, we might be able to keep more of the function. Let's see if we extend this chart. What if we went in the opposite direction? What if we included negative values, like maybe negative pi over 2? Well, negative pi over 2 would be going clockwise from our starting point over pi over 2. So negative pi over 2 has the x value 0. Let's see if we can plot that corresponding point. 0, negative pi over 2. Nope, that won't work because, again, we're running into this issue of having one x value produce 2 different y values. And so inverse cosine of x is only a function if we restrict its domain. Take a look at what I've highlighted in this pink box here. That's using the x value 1, 0, and negative 1, right? And everything in between. So inverse cosine is only a function if we capture this part of the original function. So for cosine of x, we have to restrict its domain to the interval from 0 to pi. We can include both of those values because we don't have any overlap in the resulting inverse, so that the inverse cosine of x is a function. Otherwise, inverse cosine of x is not a function because one x value produces 2 different y values. Okay, let's take a look at another example. KV was asked to determine the domain, that means the x values that we're using, and y equals the log of x. to see whether log of 0 is defined. That's our big question. Is the log of 0 defined? We'll know that by knowing the domain of the function. He started to panic. Okay, that makes sense. Log of x isn't the most familiar function to some of us, but domain is easy once you have a graph. He doesn't recall what the graph of log of x looks like, but he does recall that y equals log of x is the inverse of the exponential function y equals 10 to the x. That's because this is the common log with an unwritten base of 10, right? The exponent with base 10 and the log of base 10 are inverse functions. Assuming this is a no calculator question, help KB make a table of values of this function, our inverse function, and use it to answer the question. Okay, this is a fairly involved question the way it's written, but it's essentially saying if you find yourself stuck, use something you know to figure out something you don't know. And we know that if we have 10 to the x power, anything to the 0 power is 1. That's an easy point. So 10 to the first would be 10. 10 squared is 100. 10 cubed is 1,000. We're starting to get a sense of what's happening, right? The exponential function is growing at a growing rate, increasing at an increasing rate. What about negative 1? Well, 10 to the negative 1 is the same thing as 1/10. And 10 to the negative 2, we can make that exponent positive by putting it in the denominator. So this is 1/100th. And 10 to the negative 3 is 1 over 10 cubed. That's 1/1000th, and so on. Okay, we're ultimately trying to figure out if the log of 0 is defined or undefined. So let's take a look at the log function, right? If this is our function 10 to the x, we can very easily make a chart of the function log of x. You could call it the common log of x, or log base 10 of x, or just log of x, right? We know that we're going to have these same coordinate pairs because f of x and y are inverse functions. We're just going to switch the inputs and outputs. So 1/1000th becomes an input associated with the output negative 3. 1/100th becomes an input, and so on. So maybe you can look at this table of values and determine if the log of 0 is defined. Maybe you can't. Well, maybe you're looking here, but keep in mind this is an output, whereas we want to put log 0 into the function. If it's hard for you to imagine, then draw a picture. I'm a pretty visual person myself, so let's see what's going on in this graph. Okay, 1/1000th is a tiny, tiny, tiny number, very close to 0. Right? Maybe we'll put 1 here just to emphasize. And 1/100th is, again, very close to 0. 1/10th, again, sort of here. Maybe 1/0 would be the point here. 10/1 would maybe be the point here. And 100, 1,000, oh, you can see, I'm sorry, 102, right? To get up to the y value 2, you have to go way, way, way over to the right. So let's connect these dots and see if we can tell what's going on. We want to know, back to our original question, can you use 0 as an input into this function? Well, it doesn't look like it. It looks like we have a vertical asymptote at x equals 0, which means that 0 is not a value you can substitute into the log function. Well, if we go back to our more familiar exponential function, we remember that 10 to the x looks like this. And indeed, 10 to the x has a horizontal asymptote at y equals 0. So it would make sense for our log function to have a vertical asymptote at x equals 0. Because our function has a vertical asymptote at x equals 0, that means it will never actually use the x value 0. And therefore, we can conclude that the log of 0 is undefined, since log of x has domain the interval from 0 to infinity, just not including 0.